Hello dear students. Today in this session we would learn about decimals. That is, we are going to start chapter number 7, decimal fractions. First of all, just recall the concept and solve exercise given in revision section. We are going to start the chapter with the topic understanding decimal fractions. If 1 is divided by 10, then in common fraction it is written as, like you can write it as 1 upon 10. And in decimal fraction you can write it as 0.1. It is called 1/10. It means we are just taking one part out of 10. So when we just talk about one part out of 10, we can say it is 1/10. 1 upon 10 is called 1/10, and in decimal fraction it can be represented as 0.1. If we consider one part out of 100, it is called 1/100th. When 1 is divided by 100, we can write it as 1 upon 100. It is called 1/100th, and in decimal fraction it can be written as 0.01. And if we consider one part out of 1000 parts, each part is called 1,000th, means 1 upon 1000. It would be common fraction for this number, and in decimal fraction we can write it as 0.001. So these are common fractions and these are decimal fractions for these numbers. Fractions with their denominators 10, 100 and 1000 are known as decimal fractions. They are written in different ways. Like we write them as the common fractions. We can write them with starting with points and digits according to their values. The decimal fractions can be written using a point, that is called decimal, and the other digits are written according to their places, like whether they are at the place tenths, hundredths or thousands. So if we just take one part, means one ones, we are taking just 10th part. 10 tenths is equal to 1/10 equal to 10 hundredths. These are the relationship between them. 1 equal to 10 tenths, 1 equal to 100 hundredths, 1 equal to 1000 thousands, 1/100th is equal to 10 thousands, and 1/10 equal to 10 hundredths. Whole numbers and decimal fractions are combined as follows. Like if you are considering the number 3.2, this is called 3.2. This would be read as like this: 3 decimal 2 or 3.2. 3 is the whole number part and 2 is the decimal fraction part. Decimal places here is 1 and the 0.2, 3.2, that is the decimal part, and the whole number part is written before the point, that is called whole number part. Here the number is 3.2, means whole part is 3, whole number is 3 and the decimal number is 0.2. So this is, again I am telling you, in 3.2, this is the decimal part, this is decimal, the dot, this is dot, dot means decimal, dot is decimal point, and this is the whole number part. 3 in this case is whole number part. When there is no whole number part, we write 0 in its place before the decimal point. Suppose we consider this figure. In this figure you can see that there are 10 parts total and 4 parts are shaded. For writing fraction for this number, we can write it as 4 upon 10. Common fraction for this figure is 4 upon 10 for the shaded portion. 4 portions are shaded out of 10, so the common fraction would be written as 4 upon 10. And in decimal fraction, this can be written as 0.4. 0.4. There is only one place after decimal, 0.4. If we consider this figure, the complete one whole is also along with the other figure in which there are total 10 parts and 3 parts are shaded. So the shaded portion would be written as 3 by 10 and the whole number would be written as 1 because there is one whole. And when we add those numbers together, we get 1 plus 3 by 10 or 1 plus 0.3 and the total number would become 1.3. This is the whole number part 1 and this is the decimal number part 0.3. Point is written between the whole number and the decimal part. So this number is 1.3. Similarly, this number is 1.7 because one whole is complete here and the fractional part is 7 parts are shaded out of 10. So 7 by 10 means 0.7. Total number would be represented as 1.7. In this case, you can see that there are 3 whole numbers, 1, 2, 3, total would be 3, and the fractional part is 3 by 10. So, this number would be 3.3. If we consider this number, this is, first part is, there are total of 10 parts and 3 parts are shaded. So, this would be written as 3 by 10. 3 by 10. First part is 3 by 10 and the second part is there are total of 100 parts and from those 100 parts only 8 parts are shaded. So, that part would be 8 upon 100. When we add these numbers, firstly we would write them as fractional numbers 0.3 and this would be written as 0.08. When we add these numbers we get 0.38. So, this is the number for this figure. Now, here in F part you can see that there is one complete whole and out of 10 there are 5 parts shaded, out of 100 there are 7 parts shaded. So, its number would be 1.57. Firstly, we just write the whole number part, then we write the 10th part, then we write the 100th part. Now, write the number for the next part yourself. We are coming to the topic, that is expanded form of decimal fractions. We just first go through the place value chart. Here you can see that if this place is occupied by decimal point, then on the left hand side the places are ones, tens, hundred, thousand and so on, and on the right hand side the places are tens, hundreds, thousands. Here in this class we would learn the decimal fractions up to the places thousands. So, now the place value chart contains the places like after decimal the places are tens, hundreds and thousands, and before decimal means on the left hand side of the decimal there are normal, as you write the numbers in Indian place value chart, as the whole numbers are written, the places are ones, tens, hundreds and thousands. Suppose you are given a number and you are asked to write the place value of each digit in the given number, and the number is 3893.574. This is the number. Firstly, we would write the digits in proper places. You know that 3 would be written in the thousands place, thousands column, 8 in the hundreds column, 9 in the tens column, and then 3 would be written in the ones place. Now, in the 10th place we would write 5, in the hundredths place 7 would be written, and in the thousands place we would write 4. As it is occupying thousands place, so its place value would be 3 multiply 1000. You know that place value is face value multiplied by the value of its place. So, now it is lying in the thousands place, so it would be multiplied with 1000. 3 multiply 1000 gives 3000. Now, we come towards the place value of digit 8. It lies in hundreds column, so 8 would be multiplied by the number 100. 800 would be its place value. 9 is in tens column, 9 multiply 10 gives 90, which is its place value. 3 is in ones place, 3 multiply 1 gives 3, 3 is its place value. Now, we come towards the decimal part. After point, we are getting 5 in tenths column. Tenths column means we are writing the number as 5 upon 10, that is 0.5. And now 7 is in hundreds place, 7 upon 100, 0.07. And 4 is in thousands place, so it would be written as 4 upon 1000, and in decimal fraction we can write it as 0.004. This is the place value of 4 in this number. So, expanded form of 3893.574 would be 3000 plus 800 plus 90 plus 3 plus 0.5 plus 0.07 plus 0.004, or you can write it in the common fraction also, that can be written as 3000 plus 800 plus 60 plus 3 plus 5 upon 10 plus 7 upon 100 plus 4 upon 1000. So, you can write the expanded form like this. Equivalent decimal fractions. Now, we are going to do this topic, equivalent decimal fractions. Suppose you are given a fraction 9 by 10 and you are asked to find 2 more equivalent fractions, then you can write it as 9 by 10 can be written as 0.9. Now here the number is 9 upon 10 and in decimal fraction it can be written as 0.9. To find equivalent fraction, we would just multiply the numerator and denominator with then 10, then 100, then 1000. You can write any number of equivalent fractions, whatever you want. Firstly, we are writing the first equivalent fraction by multiplying the numerator and denominator with 10. Suppose we are multiplying it with 10 and also we are multiplying the divisor. Divisor means the denominator. With 10, it would become 90 upon 100. And 90 upon 100 can be written as 0.90 or 0.90. You know that if there is no whole number part, you can write a 0 over there. So, in this way, this number would become 0.90. And similarly, when you multiply numerator and denominator with 100, then you would get 900 upon 1000. And that number can be written as 0.900. It means if you are having a decimal place single digit, then or double digit maybe, like you may get 0.95 also. You can just put one more zero, two more zeros, three more zeros in the decimal part on the right hand side to get the equivalent fractions. Because you know that if we just write 0.9 or write 0.90 or we consider 0.900, all of these are having the same value, that is 0.9, because the 0 present at the end of the decimal part has no meaning, has no value. But for making equivalent fraction, we can write zeros to make them equivalent, like 0.9 can be written as 0.90 or 0.900. So these all are equivalent fractions. Number of decimal places. The number of digits after the decimal point gives the number of decimal places. See, in this case, if you consider 0.9, there is only one digit after decimal. It means there is only one decimal place in this number. If we consider the number 45.706, it means it has 3 decimal places because there are 3 places after decimal. It has 3 decimal places. But if we consider the number 0.90, it again has only one decimal place because while writing zeros after the decimal point at the end of the number, it has no value. So that number, that 0 at the end would not be considered as the decimal place. So 0.90 or 0.9 both have one decimal place, but they are equivalent decimal fractions. So there is a difference between equivalent decimal fractions and finding the number of decimal places. So we do not consider the place of 0 if it is written at the end of the decimal part. So we will count the decimal places by counting the number of digits actually present having the value, which are actually have the value other than 0. But 0, if the 0 is present in between the digits, that would be considered. But if the 0 is present at the end of the number at the right hand side after the decimal part, then that would be not considered as the decimal place. So this number 45.706, this has 3 decimal places and 45.70 has only one decimal place because there is 0 at the end. That would be not considered according to the rules in the decimal places. So 45.70 has only one decimal place. Now let's discuss like and unlike decimal fractions. Decimal fractions having equal number of decimal places are called like decimal places. Whether the digits are same or not, but number of decimal places should be equal for like fractions. For example, if we consider 4.75 and 5.67, 0.03 and 100.34. All of these numbers are different. All of these numbers have different digits in their whole number part as well as in their decimal number part. But all of these have similarity that all of these numbers contain 2 digits at the right hand side, means after the decimal. It means all of these have 2 decimal places and so they would be called as like decimal fractions. So the decimal fractions having equal number of decimal parts would be like decimal fractions. And conversely, the decimal fractions which have non-equal, means don't have equal number of decimal places, they would be called unlike decimal fractions. So they can be defined as the fractional numbers which do not have same decimal places, same number of decimal places, they would be called unlike decimal fractions. For example, if we consider 1.3, 1.30, 1.300, they have same value. It means they are equivalent, but they are not like fractions because all of these are having different place values, different decimal places. So as they have different decimal places, so they would be called as unlike decimal fractions. So there is a difference between equivalent and like and unlike fractions. So keep in mind that if both, all of these, you can consider this, if these are having same value, it means they are equivalent, but they are not like fractions because they have different number of decimal places. This is how you can understand the concept of like and unlike decimal fractions. Suppose you are given that there are three numbers and you are asked to convert them as like fractions. We can convert the given numbers into like fractions, which were unlike fractions, by adding or removing the number of zeros as many as required. Like if we are given three decimal fractions 0.2, 0.54 and 5.621, you can see that first number contains only one decimal place, it contains next number 2 decimal places, and the third number contains 3 decimal places. It means we should have 3 decimal places in all of these numbers to make them like fractions, and we can put as many as zeros in the decimal part at the end because they do not change. Number of zeros at the end does not change the value of the number. So to make it like fraction to the third number, then it requires only one more place in the decimal part. So 1 0 would be put here and this number would become like fraction to this if we put 2 more zeros at the end. It means 0.200 would be the like fraction of 5.621. Or if there is number 3.621, then it is also true that that number is also having 3 places, means that decimal places over there are 3. So it means the number would be 0.200, that would be like fraction of the given numbers, because all of these numbers here should have 3 decimal places to become like fractions. So you can put zeros or you can remove zeros to make them like, because you know that we require to make like fractions if the number of zeros are required. So always keep in mind that we can make the like fractions by giving more zeros at the end.